This is problem number 10 for section 2.5. In this problem it says, for what value of a is the following function continuous at every x? So they want us to essentially find a value for a that will make this piecewise function completely continuous, right? No breaks. Let's go ahead and draw the picture for this piecewise function so far. The only thing that we can draw is this bottom part, which says that when x is less than 2, we get a value of 40. So we'll just make a rough sketch. This is 20, this is 40. And when we draw the line for this function is essentially at x equal 40 all the way up until we get to this spot of x equal 2. So you can see we have an open dot here. So really what they're asking us is, from x greater than or equal to 2, what value for a will start at 40 essentially, and then drift off this direction for x values that are greater than 2. Well, what does that really mean? That means that we need to start with a squared x plus 2a. We need that to equal 40 because we need whatever this outputs to be 40 so we can close that dot in. And we also need this to occur at x equal 2, so we're going to say that x equal 2, so we can plug this in there and we get a squared times 2 plus 2a equals 40. So we're saying that we have to have this function start at a value of 40, but we also have to have x equal 2 be the initial start for the function. So we're plugging the 2 and the 40 in. We end up with 2a squared plus 2a equals 40, and you can see we have a quadratic here. So I'm going to subtract the 40 over and get 2a squared plus 2a minus 40 equal 0. I'm going to divide each piece by 2 just to simplify it a little bit, and we get a squared plus a minus 20 equals 0. Let's factor this. We end up with a, let's see, plus 5, a minus 4 equals 0. And we can use the zero product property to say that a plus 5 equals 0 or a minus 4 equals 0. When we subtract the 5, we get a equals negative 5 or a equals, when we add the 4, 4. So it's saying that our value of a being negative 5 or a equal 4 will give us a piece of this piecewise function that makes it continuous for every value of x. Well, let's plug this negative 5 in and see what we end up with. So if we plug in negative 5, we would get negative 5 squared x plus 2 times negative 5. So we end up with 25x minus 10. And then if we do the same thing for the 4, we get 4 squared x plus 2 times 4, which would be 16x plus 8. Now we could go ahead and kind of graph these just to show what we've done. Let's pick the x equal 3 spot. So we know when we plug in x equal 2, 2 goes in here, 25 times 2 is 50, minus 10, that's 40, so that closes this dot in. Do the same thing here, 2 times 16 is 32, plus 8, that is also 40. But at the 3 spot, this is going to give you 75 minus 10, which is 65. So we can go up another 20, and that would be about right here, 65. So this would be the, we're going to call this the a equaling negative 5 line. And you can see that's going to continue going this direction forever because it's linear. And then we look at this 16x plus 8. If I plug in 3 times 16, that's 30, 48. So I end up with 48 plus 8, which is 56. And that would actually be right down here. So we get a different line that would extend forever this direction. This line would extend this direction. Either line, though, makes this function continuous for every value of x. So these are our two options here, and our two a values that we got were -5 and 4 to give us those two options.